In both CSE110 and 111, you did something called a list, right? So what's the difference between a variable and a list? A variable stores one value, right? And when we have to deal with multiple values, we use list. From outside, let's say a variable is a box that stores one value, and a list contains multiple boxes with indices where I can store multiple values. And we access each index by its index number. For example, if the list is called A and we try to access index number 3, what we do is simply write A square bracket and the index number. This is what we did back in CSE110 and 111 when we called the data structure list. In reality, from outside, let's say arrays and lists are the same things. Arrays and lists both do the same thing, and that is they store multiple values, and they are also accessed in the same way using indices, using index number. So for simplicity, for now, let's say arrays and lists are the same thing. They work in the same way. In future, for example, in future as in very near future, in the next week or so, we're going to look into lists a bit in a more detail and we'll see that lists are actually a bit different than arrays. But for now, for week 1, as এই এখন যতখানি আছি, let's say arrays and lists are the same things. আমরা যেভাবে লিস্ট দিয়ে করেছিলাম use করেছিলাম back in CSE110 and 111, we're going to use arrays in the same way in CSE220. There's nothing to panic. A lot of people are getting scared when they hear the word arrays. বলছে আমরা অ্যারে করি নাই, ফাইন, তোমরা অ্যারে করো নাই, বাট তোমরা অ্যারে করেছো আসলে CSE110 111 অ্যারে করেছো লিস্ট নামে। হ্যাঁ, যদিও আমরা ফিউচারে দেখবো এই অ্যারে এবং লিস্ট দুটো ভিন্ন জিনিস, বাট ফর নাও লেটস সে দিস আর দ্য সেম থিংস and they work in the same way. ঠিক আছে, এখন কিছু জিনিস আমরা একটু ভিন্নভাবে করব in our quizzes and assignments. In list, while using list, we use something called append, right? We use built-in functions, append, delete, index, and so on. There were a number of multiple built-in functions. এখন আমরা 220 তে আমরা built-in function গুলো usually প্রথম দিকে ইউজ করব না, so that we really understand how the data structures are working. আমরা append করব না, আমরা কি করব, কষ্ট করে append মানে কি, adding at the end, right? আচ্ছা, আমি একটা নতুন একটা পেজে যাই, এখানে লিখি। So append means adding an element at the end. So in CSE220, instead of using this function append, what we'll do is we will add a number, add any value manually without using any built-in function. Same as delete. Like in Python, if I have a list containing 3 numbers, if I delete the middle number, the resultant list looks like this, right? And we do not have any empty space or blank space between these numbers. In 220, we are not allowed to use the delete function. We have to delete manually. That is, and how to do that? First, I make this box 0, and then I do a left shift. Then what happens is the resultant list will look like this, which is exactly this. If we had used the built-in function delete, this would the result would look exactly like this. But in CSE220, we'll see that we'll not be allowed to use these built-in functions. So today I'm going to spend some time for about 20 minutes, 15 to 20 minutes on arrays or list. We'll use these words interchangeably for the first 2 weeks. Any questions so far? Okay, if there are no questions, we'll move to the next thing. Let's say we have to insert an element for example, a number 5, an index number, let's say 3, in a given list, or I might say array. Before I write the code, I'll draw the diagram to visualize what would happen. So this is a given array or list, and I have number of elements. For example, I have 5 numbers, and I have to insert the element, the value 5, inside the index number 3. That is, and for example, I have empty spaces. So I have a list or an array of length 7, and at index number 3 I have to insert the element 5. What we'll do is very simple. We will right now this particular index is not empty. So what we have to do is we have to move these elements to the right to make this spot empty. In the first week, I taught you left and right shifts, right? So what I'll do is I'll use a right shift I'll call the right shift function on these 2 elements only. Look, I'll not call a right shift. I'll not shift all the elements to the right. I'll shift these 2 elements only because I have to make this particular box available for the new number to be inserted. Therefore, these numbers will remain as they are, and these 9 and 10, these two numbers will be shifted one space to the right. And we'll see that this space is not available, and then I'll insert the new number 5 at index number 3. Did you understand? Well,
Yes, teacher.
I'm not getting any response, yes or no.
Yes, teacher. I understand.
Now, do not get panic if you see the word array instead of a list. They mean the same for now, okay? Acha. Now let's see what happens when we delete an element. We have an array or a list with numbers, and we are asked to delete the number at index 2. So what now let's draw the diagram. The first thing we need to do is we make this element 0. 0 means I have deleted the element. 0 also means a blank space. Now what we have to do is remove the blank space. We remove the blank space by using left shifting these two numbers. I do not have to shift all the numbers, because if I shift all the numbers, I'll lose 3. My job is to fulfill this particular spot, because this spot right now is empty. I cannot leave any empty spaces. Therefore, to remove the empty space, I have to left shift these two elements. So after I do a left shift, this is a resultant list. Now these tedious work could have been easily done using built-in functions add and delete. Fun, uh, Python list supports Python lists support these built-in functions where I can easily add and delete elements at any index. But in 220, we'll do this manually. We'll not be allowed to use these built-in functions. All right? This is so that we understand what's happening inside. Now, before we move to code, we must understand the scenarios or what's happening. Okay? If we do not understand what's happening, if we cannot draw, if we do not draw, coding will not help. Once I draw the scenario, coding becomes really easy. Okay, I can look at the diagram and I can code. So is there any question before I move to coding? Do you understand what happens when we delete an element and when we add an element?
Yes, sir.
Okay, great. Now let's say we have to add an element. We have to add an element at index I, add an element x at index I in a given list A. Or you might see the word array A. Before you go to code, always draw the diagram. For example, this is a given list and I have some numbers. For now, let's say the list has at least one empty space. Okay, the list has at least one empty space. So this is a given list. Let's say I is 1 and the number x is say 28. So what I have to do is I have to insert the number 28 at index number 1. That is, there is what I have to add the number 28 at index number 1. At this point, this spot is not available. In order to make this spot available, I have to move all the elements starting from here to here, one space to the right. This one will remain as it is. I'll not touch one. I'll move the elements from the given index I to the last uh, till index to one space to the right. Okay, before I start coding, there's one thing I need to tell you. You'll come across two terms, length of a list or length of an array, and size of a list or size of an array. Length and size has two different meanings. Length means capacity of the list. Capacity means how many values the list can store. And the term size refers to number of elements present. So if we look into the list A, the length of A is 5 because I can store a maximum of 5 elements. This particular list has a capacity of storing 5 values. Therefore, the length of the list is 5. But the size of this list is 4 because right now there are 4 elements present. If I have an empty list of this, for example, this is an empty list. The length of this empty list is 4 because the capacity of this list is 4. The capacity of this list is to store 4 elements maximum. But the size of this particular list is 0 because right now there are no elements present. So this is a very important concept of length and size. So I'll have to write a function a method named insert, where I'm given a list A, the value to be inserted, and the index where to insert, and size of the list, which means the number of elements present inside the list. Looking at the diagram, the first thing we must do is we must empty the spot pointed by I. Therefore, I have to shift all the elements from this index to this one. Now recall the code of right shift. First, I save the value size to I. Oh no, we already used I. Let's use a different variable. Let's say U. So this is U. I'll shift 4 to this one. Or better, let's do this. Easy. What if the size is not given? The best way would be length of A minus 1. Therefore, U points to this particular index. What I'll have to do is I have to move 4 to U. That is, I have to shift the element from the previous index to the current index pointed by U. That is, list of U will have U minus 1. And this will continue in a loop until U reaches I. Now let's trace. Let's see if my code is correct. According to this line, this is U, and while U is greater than I was 1. U is definitely greater than I, so I shift the number at U minus 1 to U. That is, I shift the number 4 from this position to this one. Look, when we shift, this number does not disappear. This does not get removed automatically, because what we're doing is we're copy and pasting, not cut and pasting. Okay, we might have the notion that if we move the element from one index to the other, this will get actually moved, I mean physically moved, but we're not doing that. We're copying and pasting. Now we have to move U from U. We have to decrement U. Now U moves to index number 3. U is still greater than I. Therefore, we shift the number 3 to this index. Decrement U. U is still less than greater than I. Shift the number 2 to the next index, decrement u again. Now u is no longer greater than I. U and I is same. U and I are same, and therefore this loop breaks. Currently, I have the numbers inside the array look like this. I have successfully moved 2, 3, 4, one space to the right. But the problem is, if you remember from the last week, this extra 2 remains, which should not be a problem, and we wouldn't bother about this because we have already copied this 2 to the next index. Therefore, what we do is we save outside the loop, we insert x at index number I. This means this 2 gets replaced by 28. So I have successfully inserted a particular number, a particular value in a particular index without removing any element. What I did is I have shifted the elements to the right to create an empty space for the new element to be inserted. And I have already shown shift in the previous week. The size variable might be given or not, or might not be given. If it's not given, so this particular piece of code is not dependent on this variable. Okay. Any questions so far? Okay, now let's look into delete. We have to delete a value from a given index. For example, index I. So before we start coding, we have to draw. For example, this is my given list. And let's say I is 1. Then what I have to do is I have to remove the element 6 from index number 1. And if I remove, the resultant list should look like this. I'll remove 6, and after I remove, there will be an empty space. Removing means making it a 0. If I make this particular index 0, 0 means an empty space. I cannot keep any empty spaces between numbers. Therefore, what I have to do is I have to shift all these numbers one space to the left. And after I do that, my resultant array or list should look like this. And we know from the previous week that when we shift, the empty space at the end or at the beginning will be a 0. Now let's code. This is the function. This is the list and this is the index. The first thing I need to do is I make it a 0. I look at the diagram and follow the steps. I made it a 0. And then I have to shift the elements, all these elements, all these 3 elements to the left. And notice that this particular 5, the first element is untouched. Therefore I have to shift from this particular index, which is I. So let's take a temporary variable x, save I in a temporary variable. Then what I do is I shift the number after x to this one. So the spot pointed by x will have the number pointed by x plus 1, the next number. And this will continue until length minus 1. Because if I reach length, and from length, if I try to access plus 1, I'll get an error message. My program will crash. Therefore, I'll stop my program when this x reaches length minus 1. Therefore, my loop should look like this. Oh, sorry. So it is less than length a, not less equal to length a. Therefore, when x reaches this particular index, I stop. I do not further do any shift or copying any element. So let's trace. Let's see if my code is correct. At first, this is I. I made I 0. And then I took a temporary variable named x and saved the value of y in x, which means x also points to I at the same index as I. Now, as long as x is less than length of a, yeah, this condition is true. Therefore, I go inside the loop. I save. I move the next value to this one. So this 0 gets replaced by 9. Increment x. X is still less than length of a. 9 gets replaced by 10. Increment x. X is still less than length. So this 10 gets replaced by 11. This is happening exactly what I wrote over here, moving the next element to the previous index. Increment x. Now x has reached length of a. X has reached length of a, which means my loop stops. When my loop stops, I have an extra 11 at the last index. What I have to do is I have to make it a 0. So outside the while loop, I do this. Because I know x points to the last index, therefore I can use x and make it a 0. So any question with delete?
No, sir.
Okay, I hope you guys are understanding.
Yes, sir.
Okay. Now we'll look into a new data structure called a circular array. Do not get scared by this word, okay? List and array for now means the same thing. Whenever we hear the word circular array, so far the list we've dealt with looked like this, right? This is called a linear array. This is something we've been doing since CSE110. We've been using linear arrays. Today we know a different array named circular array. Whenever we hear the name circular array, we might think the array looks like this. We might think the array looks like this. But the funny thing is, nothing like this exists. Does not exist. Then the question is, where does this word come from, Mani? Then why are we using the word circular? Then how does the circular array look? The answer is very interesting. We use the linear array, this one, the regular array, in such a way that it seems we are using a circular array. We're gonna get the feel that we are using this, but actually we'll be using a linear array. But the technique of using the linear array will be a bit different. All right? Let's look at this example. For example, I have a number of students in my classroom, and they have names. These are their names. And I ask you to, and I give you a task. I give you a task. And the task is print the names of all students, but starting from the third student. Your task is to print all the names of the students, but starting from the third student. That is, I'll have to start from. So if I say, let's say third, so 1, 2, 3, let's say 0. As we are computer science students, let's start with 0. So this is the third student. Then what should the output look like? The output should look like BKXZMA. Why? I start from here. I print B. I move to the next. I print K. I move to the next, print X, move to the next, print Z. Now I've reached the end. But I have 2 more students left. What I do is I circle round. I circle round. I take a U-turn and print M and A. And then at this point, I'm done printing the names of all students, and this is where I stop. Did you realize something? These students were arranged or seated in a linear manner. Look, I could easily represent these students using a linear array or a linear list. But the way I've printed the names, I went a bit circular. Look, look at the pattern. Circle. These students were seated in a linear fashion, but I've printed their names in a circular way. So this is what a circular array means. The way of traversal. Traversal means moving or loop. The way we are traversing or using the loop makes the linear array a circular array. Any questions?
No, sir.
Gotcha. Gotcha. Let's take 5 minutes break. Then we'll come back. Did you understand the idea of a circular array?
Yes, sir. I did understand.
It might initially it might be a little difficult to absorb, but as you progress and as you practice, things will get clearer. There are a few things you need to know. Starting point for a linear array or a list. The starting point of a linear array or a list is always zero. We always start from index number zero. But for a circular array, it could be any valid index. This is a linear array. We start from index number zero always. This is a circular array. We start from index number two. Look, the elements in these two arrays are arranged in the same way, but starting from different index. In a circular array, always remember that the index could be any index. I mean, the starting point could be any index. By valid, I mean the starting point cannot be a negative number. Of course, we cannot have negative indices in an array, and a starting point cannot be beyond the length. It cannot be 4. You got that? The starting point of circular array will always be given. Otherwise, you wouldn't know where this. I mean, you wouldn't know where the numbers reside. And make sure you do not lose the starting point. For this particular array, the starting point is index number 4. Make sure that you always remember, you mean your program always remembers the starting index, because if you lose it, for example, if you lose it to 5, you lose it, and your index number mistakenly changes from 4 to 5, the starting point changes from 4 to 5. Look, the whole scenario changes, the sequence changes. When it was pointing at 4, the representation of the numbers were 1, 2, 3, 4, 5. And if it changes from 4 to 5, the starting index, the representation number changes to 2, 3, 4, 5. Please make sure that your code, you do not write a code where you change the starting point. And there's one more thing you need to know, that is you cannot have empty spaces between two numbers. Now, these are also empty spaces. By two numbers, I mean, look, this is the number representation 1, 2, 3, 4, 5, and these empty spaces are after the numbers n. By two numbers, I mean I cannot have space between 1 and 2. 1 space, 2, 3, 4, 5. Or 1, 2, or there's a space between 2 and 3. Or there's a space between 3 and 4. Or 4 and 5. These spaces between numbers cannot exist. Yeah, there can be empty spaces after the numbers. For example, the capacity, the length of this particular array is 6 or 7, but the size is 5, which means I have 5 elements inside the array. And naturally, I'll have two blank spaces because I'm not covering all the empty spaces. That's not a problem. By empty spaces, I mean there cannot be empty spaces between the representation of the numbers. These numbers have to be compact. 1, 2, 3, 4, 5 is a compact representation. Questions so far?
No, sir.
Acha. Now we'll look into coding a bit, a very, I mean, a simple code where I'll be given a circular array. The starting point, let's say the start, and the size of the array. We already know what the size of the array means. And we have to print. We have to print the elements. So before I start coding, I'll always draw the scenario. Let's say this is my circular array. And for example, 4 is my starting index. Let's say this is S. And I have 5 elements, and the empty space is always represented using a 0. This is what is given to me, and the result of print should look like this is what I have to print from the given array. Once we draw the scenario, we'll start coding. The first thing I'll do is I'll save the starting variable in a temporary variable. I'm saving the start in, oh, sorry. Let's say this is start. Start is a variable that contains the starting index, and I am saving the value of start in the temporary variable s. I'm doing this because so that while I'll be working with s, I do not I do not lose the original value inside the start. As I mentioned a bit earlier, that we don't want to lose the starting index. The first thing I need to do is print. So I print when I print the number pointed by s, I get 1, which matches with my output. And then what I have to do is I have to increment, this is s, I have to increment s from this index to this index. Done. Then again I print s. 2 is printed. Then again I increment s. But the problem is, if I increment from this position, s goes beyond the length. So what should we do? Try to recall when I showed you the student example. When we go beyond the length, we go back to 0. Remember? So how is it done? We do a check, an if condition. If this variable goes beyond the length, or which is equal to length, which means length means I've reached over here, index number 6. I go back to 0. This is very important. I keep on printing, I keep on moving forward until I reach the end, or reach a dead end. When we reach a dead end, we take a U-turn back to 0. This condition is what makes a linear array a circular array. Now the question is, this must be done inside a loop. This whole printing thing must be done inside a loop. Now the question is, what should be the condition inside the loop? How many times should I print? This is a very tricky part. For this, I'll take an extra variable, let's say I, which I'll initialize to 0. And the condition should be while I is less in size. Now let me explain. This is a bit tricky. I want you guys to concentrate. No matter where I start printing from, at this particular example, I'm printing from the index number 4. No matter where I start printing from, I'll print 1, 2, 3, 4, 5 elements, because there are 5 elements present inside the array. Even if the start was over here at this index, or at this index, or at any valid index, no matter where the starting index is, I'll print 5 elements because there are 5 elements present. Therefore, the printing must be done 5 times, or size number of times, because size contains the number of values present. Therefore, this I is actually for counting how many times I've printed, or how many elements I've printed. I start I from 0. When I is equal to 0, I print the first element, 1. I increment I over here. When I is 1, I print my second element, 2. When I is 2, I print my third element. When I is 3, I print my fourth element. When I is 4, I print my fifth element. When I is 5, which matches with the size, my loop breaks. This means I have printed 5 elements. Using this variable I count the number of elements I'm printing. And with this variable s, I'm actually printing the elements because the numbers do not start from 0. When we write a loop for a linear array, we just use one variable. This is because the starting point of a linear array is 0 always. But for a circular array, the starting point is not 0. Therefore, we need to keep 2 variables. One variable for keeping the count of the number of values I've dealt with, and a separate variable to actually print or to actually do the job, which starts from the starting index. I hope I could explain. This is the trickiest part. Once you understand how the list loop works, circular array is pretty straightforward. Any questions so far? We're at the end of the lecture today.
No, sir. I understood the whole concept.
Acha. If you do not have any question, we'll end the lecture over here.
Okay, sir.
I'll post the recordings. I'll post the recordings of today's lecture and other lectures as well. I've already taken 3 lectures on circular array in different sections. I take 4 sections. You may look into the other lectures as well. Okay, other live recordings. I'll post them all together.
Okay, sir.
Okay, if you do not have any question, you may leave. It's done.
Okay, sir. Bye.